Good morning. Today we're going to talk about areas of triangles. So, fun fact, this is our last lesson of the year. You should get excited for that. All right, so what we want to do is try and figure out how we can calculate the area of a triangle using trigonometry. And we think, well, why do we need to use trigonometry? We know some of the formulas for triangles. Well, our first formula that we would look at is this for the area. It's something we remember from even middle school. It's 1/2 times the base times the height. Now that's the area formula in general, but some of the components are kind of hard to find, right? So the first thing we can see is let's try and identify each of these components. Well, I know what the base is. The base is pretty simple. It's going to be that bottom line. So that is side B. Okay? So the next thing to try and find then would be the height. Well, how do I find the height? Okay, well, we can draw the height of the triangle by drawing something perpendicular from the base up to the tallest vertex. That right there is going to be the height. Okay, well, I still don't know what that height is, but now I start to see that, look, I have a right triangle. And so long as I'm given one of these angles, let's say we are given angle C, then that means I know that my height is the opposite side. And then I can see that side A is actually the hypotenuse of this right triangle. You may think, okay, well, wait, trig stuff. I know trig stuff, and I know opposite and hypotenuse, that has a relationship. And that means that sine of the angle C is going to be equal to the opposite side over the hypotenuse. Because we remember SO katoa. So, SOH, sine of an angle is the opposite over the hypotenuse. Okay? So now what that means is I can replace height with some kind of relationship here. So let's do a little bit of algebra by replacing a couple of these things. And we'll say that, okay, my hypotenuse, we know that that is side A. Now here's what I want to try and do. I want to get the opposite side because that's the height that I want. I want to replace that. Okay, so let's go down here a little bit and just try and jump down to where we can work with this sum. Give myself a little bit more room. And I have, so far, sine of angle C is going to equal the height divided by side A. Well, we can do some quick algebra here, and we can solve for height by multiplying both sides by that side A, the hypotenuse. A's on the right-hand side are going to cancel out, and I'm now left with height is equal to A times the sine of angle C. Okay? So now let's go ahead and replace some things in here that we know. We know that the area is not going to change. Area stays what it is. The 1/2 is a constant number, so that stays what it is. But the base, we said that that was side B. And then the height, we said that that was going to be equal to this thing down here. A times the sine of C is equal to the height. So that means I can replace the height with A times the sine of C. And now we have some things that are written out in terms of just the sides that we have and one of the given angles where we don't have to necessarily know the height of a triangle. And we'll generally rewrite this in this way, that area is going to equal 1/2 AB sine of C. And this is going to be a handy area formula that we can use. Now, what we want to pay attention to, or at least notice with this, is that we have A, and we have B, and we have C. 3 different letters. 2 of them are lowercase, and 1 of them is uppercase. Remember, lowercase letters are going to always be representing sides. Uppercase letters are always going to be representing angles. So what this means is that we have a side angle side triangle, where there are no corresponding angles or sides. Each letter is different. And that helps us identify pretty quickly whether it's from just text, where we're just given 2 sides and an angle, or we're given an actual drawing, when we can use this formula. So, this formula will only work for side angle side triangles. what if there's some other information? Well, we actually have another formula that's fairly easy to work with. Not so easy to remember, but easy to work with. So let's take a look at that. And that formula is called Heron's formula. Heron's formula is equal to this. Area equals S times S minus A times S minus B times S minus C, and we take the square root of all of that. Well, that's really gross, and we don't even know what's S. Well, S is going to equal A plus B plus C over 2. So let's break this down a little bit and at least recognize that I have A, B, and C. These are all 3 sides because they're all lowercase letters in a triangle. So what that tells me then is that this is going to work for any side triangle. Anytime we have all 3 sides, we're going to be able to work with this formula. But what about this thing S? Well, S is given to us here, and we see that that's A plus B plus C divided by 2. And think, well, hey, A plus B plus C, that's where I'm adding all the sides. Adding all the sides, I can remember that, where that's just the perimeter divided by 2. That's another way that you can start to think about S and make it a little bit easier for you to remember and work with. But remember, for the most part, you're going to have resources available for you, whether it's on a note card or formula sheet. You're not going to have to memorize this formula, but for the purposes of our notes and for your future, you can try to work with this. So now let's go ahead and take a look at a couple of examples. First example we have is this triangle here that is a side triangle. I know it's side because I've got all 3 of the sides here, 43, 53, and 72, which means we should be able to use Heron's formula. I like to always, when I'm first learning a new formula, to write it out just so I can remember how the thing works. So the area, I need to go back and just double check. S times S minus A times S minus B times S minus C inside my square root symbol. So I have S times S minus A times S minus B times S minus C. Close the parentheses. So the first thing I need to do is find this value of S. S is found by taking the perimeter, so that's adding together all 3 of these sides and dividing them by 2. So let's go over to our calculator and punch that in. Make sure that you are putting these in parentheses whenever you're using your calculator. Just parentheses are going to make sure that you're following your order of operations correctly. So we have, opening up the parentheses, 43 plus 53 plus 72, closing the parentheses, and I'm dividing by 2. And that gives me a value of 84. So that's that value S that we can plug in. Okay, so we know that S equals 84. Now it doesn't matter which one A, B, or C really is. You can plug them in anywhere you want. So we have A is going to equal the square root of S, 84. I'll go ahead and write in my parentheses here so I don't kind of forget them. 84 minus S, I'll call S the first side I see, 43. And then we have 84 minus the next side I see, 53. And then I have, again, S, 84, minus the last side that I see, 72. Now, nice thing is, all numbers, right? Once we see all numbers, we can plug this in directly into the calculator. So let's go ahead and do that. We'll go back to our calculator. And we go to our square root by hitting the Control and then the X squared button. 84, parentheses, 84 minus 43. Close the parentheses. Open them up again, 84 minus 53, close the parentheses. Open them up again, 84 minus 72, close the parentheses, hit enter, and there is my area, 1,131.89 units. We'll go and round to the nearest tenth, so 0.89 tells me to round up to 0.9. So our area is going to equal 1,131.9 units squared. That's it. Easy peasy, right? So anytime you got a side triangle, you can go ahead and use this Heron's formula. Let's go ahead and take a look at another example. Next one, I see that I've got a side an angle sandwiched in between another side. So that tells me that we have side, angle, side, and that is indeed an SAS triangle. Okay, anytime we have the SAS triangle, we know we can't use Heron's formula. What we're going to have to use is A equals that 1/2 A times B times the sine of angle C. Okay, so here's the thing to notice here. We don't have A and B and we don't have C, but we have the given sides and the given angles. So this should be fairly easy to plug in. First thing we can do, A we know is not going to change. 1/2 is not going to change. But what's A? A is a side. Pick a side to start with. I'll pick this first one, 15. B, that's a side. What side should I go with? It's the other one that I have, 11. And then finally we have sine of the given angle that's in between those two. The angle that's in between those is 130 degrees. Again, I see that I have all numbers, straight up calculation. 1/2 times 15 times 11 times sine of 130. Let's go to our calculator. And we have, I'm going to open up my parentheses for the 1 divided by 2. And then I have A, 15 times 11 times the sine of 130 degrees. And there we have it. 63.1987. We'll go in again, round to 1 decimal place, so 19 rounds up to 0.2. And that means we have an area of 63.2 units squared. So this is really just all calculator work. You have a little bit of a challenge in deciding which formula to use, but really this is it. All you got to do is decide, is it SSS or SAS, and that's it. Now sometimes you might have to use a little bit of trig to solve the puzzle. Are you able to find a third side? Maybe you can use law of sines or law of cosines or something like that to try and find the third side. Maybe you can use law of sines to find an angle in between those two. So the last thing that you want to really address is down here, that this formula only works when you have no corresponding sides and no matches. Okay. The other note that we want to address is that, you know what, you're just going to have to try and work with this formula. Try to find the missing pieces. Think of it like a puzzle. Triangles are a puzzle. Use law of sines or law of cosines to find the missing piece you need. Okay, that's it. You guys should be able to apply this formula pretty easily and straightforward. Go ahead and get started on your assignment.